It's 11 o'clock. So maybe we start right away. And I welcome you. My name is Frank Fischer. Thank you for being here. Thank you for giving us the time and opportunity to talk a bit about static code analysis, static program analysis, and the product we have here, which is called Snyk. I also want to thank my colleague Melina Mathieu for making it possible and organizing it. And she's the good ghost in the behind the scenes. So if you have questions or so, as mentioned, write them down, give us your feedback, and fill the Q&A channel so that we have to talk about something later on. So my plan for today is I would like to split it literally in like 3 parts. I have some slides to start with, simply to kind of give you a kind of guidance where we are, how does Snyk code fit into all of this? What is the idea of Snyk code? What makes us in a way a bit special? That's the one side of it, and this will be on slides. My idea is that this is like the minority of the time. The majority of time I would like to spend in a little scenario. And what I prepared here is me being the developer. So we're literally following the life of a PR request, and we will see where Snyk code comes in, and it comes in kind of naturally. We don't have to wait long and things like that. You will see, and I hope it's kind of a bit amusing on the one side, but on the other side, it shows you the kind of benefits that we have with Snyk code. After the demo, I wrap it up with a few slides, and then we can open up the panel for any kind of questions that you would have, and any kind of feedback you would like to give us in this regard. Okay, so let's start with this. So I'm the product marketing manager for Snyk code, but I'm proud to have a bit of a technical muscle, and I hope you will see that during the demo. So I used to be in companies like Google and Microsoft, and I have a kind of, as I said, the technical muscle. I used to work as a CTO in startups, in companies like Google and Microsoft. I used to work as developer relationships, so I saw both sides of it, and I think I'm okay talking about it. I also studied a bit the program analysis, the static part of it, and I hope I can sort of say geek out a bit and talk a bit about technology, not too much, but a bit. Okay, so when we're talking about Snyk, one thing I learned yesterday, because I met 2 startup founders and they were asking me, okay, Snyk, what is it? So Snyk is, I think, no longer a kind of startup. Now we can call it a grown-up. We are in the space of developer security operations, so DevSecops. This is where we focus on. And we are in the good situation that we have a lot of very well-known clients within the community. That said, we are also part of that community. So we are part of the open source environment. We are giving back in this regard. We are part of security initiatives in this area. And this is Snyk. We are now more than 800 people worldwide, and yes, we focus on DevSecops. What does this mean? We focus on DevSecops, and the idea of Snyk is probably a bit different than what you see with like the typical security vendors in this area. Our idea starts with the developer. If you talk about DevOps, you're literally having the developer already said. The developer is so to say in the center of the idea of DevOps, and we want to empower developers to have security as part of the DevOps process from the beginning. Right, in every step is enriched with the idea of having a security in there and increasing the security footprint of the application. And this can only be done when you are starting with the developer and you're focusing on the developer. So our idea is empower developers, give them the tools they need at hand, make it easy for them to use these tools. yes, in a word, be developer friendly in this regard. One part of being developer friendly is to automate things, to automate fixes. And as you will see in my little demo, we try to be not only very outspoken on what the things are that we find here, but also give you concrete help how to address the thing and how to remedy the stuff that you have in front of you. Plus, we try to educate you in a way that you understand what is the issue at hand, so you maybe don't do it again. You learn something and you know this is now part of your toolbox. You don't need to do this again. You know, it's part of what you know as a developer. So this is the idea that we have, very actionable, very developer focused. And last but not least, being an expert in security. And I showed you some of the customers we have. We can proudly say that the Intel database that we are using for one of our products called open source is probably one of the best in the industry, maybe the best in the industry. And I will show you now our AI-based static code analysis. And I would say it's probably unparalleled in the industry also. And there are some reasons why I say this, and I hope I can show this to you during the next hour or so that we have together. So this is the idea of Snyk in general. And now we have like the setup of the Snyk tools that you see in the wild that you can have and they can use. And by the way, all of these tools you can use for free. You can simply sign up with your GitHub account, for example, on Snyk. We also support other providers, no question, but you can sign up there and you can use the tool right away. You don't have to have a credit card there or something like this. It's just like this: sign up and use the tool. Within minutes, literally, you can have the first scan running and you see the results coming. So let's start with open source. So in the middle side of it. So this was the original product of Snyk. This was the start, and the idea with open source is to look into the dependencies that modern applications have. So modern applications use a lot of open source elements, and these open source elements need to be curated. They need to be covered with a scan that you see what is the current posture of the security dependency wise that you have in your application. So this is open source. It not only scans, it also tells you this is the weakness and this is how you overcome the weakness. So as I said, you know, we are about actionable. We are about fixing stuff. Containers is literally what the name says. We are scanning containers. We are looking at the images you are using, and we are advising you on how to improve the images that you are using in your container environment. And infrastructure as a code actually scans the cloud setup that you are using and how the network infrastructure looks like that you're using. On top of that, like the icing on the cake, you know, I'm a bit biased in this regard, is Snyk code. And Snyk code is a static program analysis, as the scholars say. It's literally looking into the source code of your application that makes your application. So the thing that makes you unique, your business secrets, your IP in that regard. This is normally in a modern application, it's only 10 to 20% of the application, but it's literally what makes you unique. This is literally what, so to say, is not available anywhere else. This is what what defines you as a business. What also comes with this is yours to keep secure. So there's no open source community taking care of this. This is your your responsibility to do that. If you look at it now from a distance, you can literally say, this is the code you write. This is the code you get from somewhere else. This is the code that defines your operating system, your environment that you're operating in. And this is the definition of the cloud that you're using. And if you're looking at this like that, it literally covers the whole stack of a modern application, of a modern cloud-based application. Okay, so coming to Snyk code and looking into Snyk code. We are using the word SAST here, or the term SAST, and SAST is Static Application Security Testing. So SAST, this is literally a kind of a fancy name for static program analysis in the field of security. So this is what we mean when we say SAST. Okay, what is that we have traditionally with SAST? Static analysis in itself is very beneficial. It's like the most left side within your development process that you can think of. So it literally starts when you write down code, when you have the first lines of code written. It can already start to scan these and can give you feedback on this. So static analysis seems to be very beneficial and very healthy. It's also everything that you find in a static analysis and you fix there doesn't make its way down the software development lifecycle. And as you know, the later you find the bug in the software development lifecycle, the more costly it is to fix it, the more time it takes. So it is very beneficial to use that. So why don't we simply use it? And there was a nice research by a university and by Google, and they found well, it's not used. So a lot of developers have what the psychologists would call approach avoidance. They try to circumvent the static code analysis. They try not to use it. And there are three main reasons, and it's also in this paper here. And the three main reasons that they are giving is, number one, developer workflow. It doesn't fit in my workflow. Okay, so when I have to do a scan and the scan takes weeks, and it's the reality. We have this feedback from a lot of our clients that with the additional SAST tools, scanning their repositories can take up to 2 weeks. So what you're doing as a developer is you are doing your job, you're coding something, and then you are entering this in the scan, then it takes 2 weeks to scan. Then the results are most often put on the head of the security guys, the security team. Now these guys have to weed through them, and there's another problem that is called accuracy. So a lot of the things that are coming out of this are actually false positives. So the tool gives you an alarm, but it's in reality it's not a problem. So the security team is now wading through this, and sometimes half of it is wrong, even more sometimes. So they are trying to find out, triaging what is necessary to be addressed and stuff like this. This takes another, I don't know, a few days, maybe a week. So like 3 weeks after the fact, now we come back with a Jira ticket to the developer, and the developer says, okay, I have no more I don't remember what I did like 3 weeks ago. So now you're asking me, so to say, to go into it, to remember what I did there, to literally understand your issue here and then tweak it. And this is an enormous cognitive load that you're putting on people in this regard. So developers don't like this kind of workflow. They would love to have it directly where they code in the moment that they code, kind of, instead of having it after the fact asynchronously later on. And last but not least, a lot of developers complain that the feedback they get from these tools are not really actionable. The tools have, from a computer science perspective, precise error messages. But from a developer perspective, you have to decode what this thing is now telling you. And sometimes the tool decoding this kind of message is really, really hard. There's actually some research going on in this direction, because it's really hard cognitively, really hard to understand what this tool sometimes means, because you then have to find the flow within the application that is literally ending up in this situation that the tool is pointing out. So it's hard to understand, and this makes it not actionable. It's not telling you what to do. It's not telling you where the problem is, and it's not telling you what to do with this problem. So it's not actionable in this regard. So these are the main complaints about traditional SAST and what we have there. What we also see in the market is people getting used to this, and applications that are providing SAST try to kind of come around these issues. So one of the things that they're providing, for example, is a custom rule set. So the vendor says, yeah, we have this tool, and we know the tool is very, very not so speedy, to say it positively. And we know the tool has a lot of false positives, but we give you the chance to have this custom rule set. So you dear Mr. Customer, you are now responsible for tweaking the rule set accordingly so that it works in your environment. It's not us, it's you now doing this, which is a kind of, they react on this. They kind of, admitted that it is, and they kind of brought up this function to overcome it by putting now the responsibility to the customer. Well, interesting. So what we do now is we disrupt this whole thing. We disrupt the market. And I want to show you in the next 45 minutes how this is done. But what also happens now to us, for example, is that we get questions asked that are simply no more to the point. And the example that I would like to make here is back from my old times, from my history. When I brought a new phone type on the market, it was not this one, but a new phone type, I was always asked about, does your phone have keys? Yeah, back in the days, smartphones were literally the requirement that we had for smartphones was have a full keyboard that I can write my text messages. Okay, so the left side phone was the state-of-the-art phone that time. And the requirement that was brought up by any kind of buyer was the more keys, the better. Now, the right side of phones came to market, and they revolutionized the market. They had a totally different UI concept. They did not need this kind of keyboard anymore. They made it different. And it was a hard time. It was a hard time to convince people that, yeah, it's actually sensible to have a phone that doesn't have any keyboard, but more screen real estate. And you will like it if you give it a try. So this was the situation we were there. Today, nobody kind of looks back on the keyboard anymore. It's hard to get one even, and everybody is now so used to the right side of phone setup, that we sometimes forget that this was the requirement back in the days. So what I would like you now to follow me is simply, free up your mind, think freshly about what SAST really means and how can SAST be helpful. Don't ask the question on, do you have custom rules? Because we don't need them anymore. As the keys here, custom rules are not really valuable as they used to be. Okay, so free up your mind. Now we start the journey. So what Snyk code is all about is speed. The speed literally enables us to do a lot of things, and I will tell you what the speed literally enables us. But it's like the major thing that we are talking about. So what does speed mean? We had the customer that I was just talking about saying we had a 2-week scan time for one of our repositories. When he did the same scan with Snyk code, no optimization, no twickering around with the rule sets or something like this, just as it came, Snyk code scan. The scan was down to 30 minutes. And the idea with this is it's still 30 minutes, but as you can see, it now becomes handable. It becomes something that you can do so and so often with your code. Maybe you can even scan the code, see the feedback, change something, scan again, and see the feedback again, and then do something and scan again. So instead of scheduling the scans, what you literally can do is you can scan all the time. So this speed allows us to do this. Another thing the speed allows us to do is to use enormous amounts of code to learn from and to test our rule set against. So what we are doing is we are taking 150,000 repositories for Python, for example. We are taking even more, like 250,000 for languages that are like Java, for example. And we are taking this massive amount of source code, open source repositories, and we are using them as a sounding board to test our rule set against, but also to learn from. So we're literally learning from the knowledge of the global developer community in this regard, by simply scanning their applications they had, see the differences, what happened between here you have a version where it was vulnerable and now there's a fixed version. What is the difference between these two? How does data flow inside of this application's work? So when we have one source function where we know this is a possible entry of tainted data, so malicious data into an application, we can literally look into hundreds of thousands of applications and see how they connect the source function with possible sync functions, how they use sanitizers in between, and what are these sanitizers. We can learn that from this massive amount of source code. Then we can turn it around and we can say we have now massive amount of possible sync functions. So now see what are functions connected to these syncs, what are source functions possibly. So with this, we can literally learn this. And by doing this, we have a process that increases accuracy, because we can sort of say test the stuff that we have on hundreds of thousands of examples that we have there. We are not only using machine learning in this regard, we are also using what is called a human guided process. So we are using the security team to kind of enable and act on this and increase the quality even more. The security team, so the engineer, is looking at it and is kind of optimizing the results that we get, is giving hints to the machine to kind of optimize it, and then running this kind of scan again and running it in a circle until we reach a certain kind of quality threshold, and then we put it into production. So this is the idea that we have with accuracy. Last but not least, making it actionable. So with this, we also have the opportunity to not only argue what the problem is and why the machine sees the problem, but also we give you examples on open source repositories fixing the issue in a similar situation that you are in. What did they do to fix the issue? So making it very, very actionable, making it easy to understand, and so to say, optimizing it to make it actionable in a way that you literally can fix it. Okay, it's not only reported, it's also reported to be fixed. Okay, so every fix that we do is a good fix. Yeah, everything that we address is good. We're not only for reporting things. This is our idea. So this is Snyk code, and the easy way of understanding what I mean with this is just showing it off, you know. And so here we go into my little demo. What I would like you to show, to see in the next probably half an hour or so, is I will use an IDE plugin to code, because I'm a developer. Okay, so I'm using an IDE plugin, and I use the plugin already to scan my code and to get my first feedbacks and to react on this feedback. Then I'm doing a PR request, so I'm pushing it, and we will see Snyk code in action on the PR. We will use the web interface in between there to see the status of things, to see how the web interface looks like and how the web interface comes into play with this. So we will use the web interface. And last but not least, I would show you the CLI, so the command line interface. I have a little Jenkins server that does, for me, the CI/CD in this scenario here. And it uses the CLI to literally scan again and see, is the code good enough now to go into production. So we'll see all of these steps in my little demo, and yeah, I hope a kind of a realistic setup that you can find yourself in. Okay, so what is my demo? We are a car sharing company now. So we have cars, and we have lots of them, and people can sort of say share these cars by simply booking one, using it, and then dropping it off in one of the dropping off stations, or maybe even park it in the public space. So as a developer, I am now tasked to build an API that actually enables partners that we have to get some telemetry data of the cars that we run. And it's a simple API, it's RESTful. Okay, they simply can query, so to say, what cars we have, and they can query the details of a specific car. So this is the tasks that we have now. My company is using Node.js, so this will be a Node.js application. And yeah, my company is in business for a few years now, so there are some libraries and stuff, maybe something that we can already make use of. Okay, so this is the setup, and now we end the presentation and we go here. So number one, this is my Jira. I'm, as I said, a developer, and I can click in my backlog, and you'll see in my backlog we have the tasks that we need to do, the API interface for the vehicle telemetry. Okay, so this is now our task. We need to work with this one. So I'm using WebStorm here. As I said, JavaScript is it, and I found when looking around, my company already has like a library, a class, something, an object that is wrapping the database for me nicely. And there's a manual text, and the manual text kind of lists the functions that we have here. And there are two functions that are actually really nice for us. So we can use these two functions, get vehicle list and get vehicle details. As typical, you know, out there, I have no idea who the guy was that wrote this. You know, this is a kind of a library that is there for long time. Probably it was one of the first things that my company developed back in the days when they started business. But everybody's using this library, so I will use it too. You know, it's there, and it's already tested. You know, and it's nice. So I will use that. A typical situation. The one thing that makes me a bit worried about things is that if I go to the Snyk interface here, so this is Snyk. I opened my application here. I opened the code analysis, as you can see, and it already found two things in this library that are not really nice. So there are hard-coded credentials in the library. You know, yeah. So what you would probably do as a security person, as an architect or so in this regard, is you would, so to say, you would like to address this. And the easy way, so to say, addressing it is creating a Jira ticket out of it. So number one, this is the web interface. You can go on full details. You know, you will see everything, and I will show it later to you also in the IDE how this looks like. You see the code, the data flow analysis you see on the code. There is a fix analysis that gives you more ideas how to remedy it. What is the detail about it? There are example fixes that you can look at. How did the open source community overcome it? You can even click on this one, and you will see what is the concrete differences that they made in this project when they overcame it. Okay, so this is our credential problem here. Okay, we have it. As an architect, I would like to create a Jira ticket. As you have seen, we're using Jira, so I can click on here, and we have an integration into Jira. So this is probably not the best developer likely one that you can use, but sometimes it needs to be, you know, because legacy code, you need to work like this. So you need to record your ticket. So you can record a bug on your ticket. You can see, you know, it's really integrated into Jira. So there are not many users on my Jira, but I can choose the users. It fills in whatever there is, and I can simply create the Jira ticket to address this problem here. Okay. So we see there's a library. Library has a bit of an issue, but it is there. Okay, it works, and I think I will use this library. So next thing that I need to do is I need to develop my stuff to get in some functions that are actually doing what I need to do. So I already prepared this because you don't need to see me typing. So what I do here is I have two functions in my little service here. The one function is the vehicle list, and the other function is vehicle ID. And what I do is I literally use my DB interface to call and to send the results out of it, you know. And it seems like yes, with this my task should be done. So let's save this and let's try if it really works. So since it is a Node.js service, I can literally start it here. Index.js. So now it listens. And I have some, where's my curl here? Here we go. I already have, exactly without the B, I have a curl that is literally asking my service. So you see my service is running. You see we have Maltese license plates. And we have some vehicles that the thing is returning. So if I then go here and I say, I want to know more about this vehicle, you know, I get more information about this vehicle. Top, this is the way our web service should work. Okay, so now that I have the web service using on this test infrastructure, I can now, so to say, switch into the real infrastructure, save it, and I think I am done with my stuff now. Okay, so now is a good moment to start with a scan. So I literally do a scan here. I started now and it's live, you know, so it collects the code, it uploads to the server, and it waits for the answer from the server. And there it is. There is the answer. So I literally, you know, the time that it probably will take me to grab for my coffee cup, I have my results here. So now I look into my index.js. This is what I coded here. The two hardline credentials, you know, the hard-coded credentials, we know about these ones, but this is actually new. This is something that I coded in here. So the first thing is it says we have some cross-site scripting here, and yeah, it's a high severity. There's a CWE, so the common weakness enumerator points me to where to description of the problem, and it says unsanitized input from data from a remote resource flows into send. So what it literally does is it uses the name of the functions that I use. So I use the function send, as you can see, and it uses the function send here as a kind of reminder. It's easy for me to kind of understand what the guy is talking about, and to literally, so to say, jump by literally looking at it, what is happening here, to see where the problem is. So I'm using the vehicle DB, yeah. So I get the data from the database, and I simply put it into send. Yes, this is not how security literally should look like. Any external data source is possibly malicious. So, you know, even my own database, I should treat it as an external data source, and I should be aware of it. And the thing is, it says the client, you know, looks at this as HTML. So the client is maybe trying to interpret what the client sees here. And this could mean I could literally send a JavaScript to the client, and the client will execute it, cross-site scripting. Okay, so what can I do with this? So if I look at it, it's true. You know, I don't say anything about what type of data I'm returning here. So maybe I should set the return data type. So I put in this line here, and I said, hey, content type is application JSON. So it's not something you should interpret. It's pure data. Just treat it as data. So I save it, and in the moment I save it, you see it's obsolete here. It says, hey, this scan was done on an old version of the file. No longer believe it. Okay, so it's obsolete. Okay, let's scan it again. So I did this line now in the hope that this line, so to say, addresses my cross-site scripting issue. And I scan it again, and you see, oh, hey, one cross-site scripting is gone. Whoa. But we got a new one here. Code quality, one issue. And it's medium, okay? So content type application JSON set in set header does not specify char set. Add char set equals UTF-8 or another char set. And it's true. I mean, it's a bit sloppy, you know, that we are not using the correct encoding here. So let's do the following. Let's simply add this char set 8 as I was suggested to do, you know. So this is literally what I'm asked now, not this one. So let's see how this would work. We are scanning again, and hey, okay, my quality issue is gone. You know, I now fix this one here. So this is a good one. Okay. Okay. Yes. Did I do something wrong here? Yeah. Okay. So let's do the following. Let's have this in here again. And the reason that I want to have it in here is simply to have something to show you later on. Just bear with me. We also leave this cross-site scripting, which is actually the exact same thing. You know, I could literally, so to say, do the exact same stuff that I did above. I could do here again. And the idea is make it actionable. Okay, get stuff together that is more or less addressed by the same template. You know, so the same pattern applies for both of them. I could, so to say, use the same pattern and it's simply done without, you know, me having extra to think about it or stuff like this. I will leave it in here now so that we have something to see later. The one thing that I want to show you now is the SQL injection stuff. And this is kind of interesting because it is something that has to do with my vehicle DB. So something that has to do with my library that I was using. Everybody's using this library, and I use it too. As long as we were using it the way we were using it, it was kind of seen as fine. But now, all of a sudden, we have a SQL injection. And if I look at my way of using it, so here, yeah, you can argue, you know, I'm taking like the direct parameter and I stuff it directly into this function call. But hey, you know, normally such a library should be not brittle towards something like this. The library should take care of things like security and stuff, right? Okay, I'm a bit naive, but yeah, I'm expecting it to do so. But when I, so to say, stuff in this type of parameter into my library, I now click into the library and you see it's jumping it's jumping files now. This is a different file that I used to work in. And the file that you see here, this is the function that it calls. Here comes the license information I stuffed into it. And it literally flows into a SQL query where it's attached, it's literally concatenated to the string of the SQL. And this is a classical SQL injection that we have here. Because of this, I can sort of say manipulate the SQL that is then executed by query in this regard. So what I want to show you with this is two things. So number one, as a developer focusing on my work, I would have never seen this if the static code analysis didn't bring it up to me, because I will never look into the depth of any library that is there and that everybody's using, and you know, it's just there and I do it. So I would probably have never seen that. The issue also only comes about because my code and the library code combined are vulnerable to this. If the library is used in a specific way, in the correct way, by sanitizing whatever is inputted there, I mean, it's not cool, and you should never have something like this to build your SQL statement. Yeah, but you know, we will see this in the wild a lot. Only by combining the two, only by combining my idea, which seemed to be feasible, and the library itself, then we have the SQL injection there, and we need to react on this. So this is something that is quite remarkable. And the next point is it's cross-file. So literally what we're doing here is we are managing the data. We are modeling the data flow of the application cross-file boundaries. So we're not only looking at the actual file, we're looking at a wide range of files that are used by your application, by the code that is kind of referencing this time. So this interfile analysis is actually a very strong one. So data flow we have here, interfile we have here. I showed you the hard-coded credential stuff. So yes, we have a lot of these typical issues, obviously, that developers do and that we can fix with this. Another thing that we need to understand here now is none of this is on the source code management already. So we didn't upload anything. All of this was done locally on my machine because I develop here locally on my machine. I scanned the code locally. I fixed the problems before they even hit the source code management system. So this means, before even going into source code management, neither going down the SDLC or something like this in the CI/CD pipeline, this is already fixed. It's something that nobody has to think about it anymore. This is an interesting concept, and this is the idea with developer first. Make it actionable, make it easy to have. Okay, so back to my demo. So now we have this. I save it and I do my commit. Select the files, commit. So now we have a commit there, and I do a pull request with this. And we know, the pull request will have some stuff in here. But the point I want to make with this is leaving it in that we can see something, and also answering one of the questions that is posed to us very, very often. What happens if a developer chooses, not to use this tool? If a developer does not, so to say, react on the static code analysis output and optimizes it, what happens then? Yeah, well, what happens then? Let's have a look on it. So this is our pull request that we just did. And as you can see, we automatically started to have checks that are running now. And the check on the code analysis is currently pending. There it is. It's done. What the check literally says is, me as a developer, I introduced 2 new issues here. To the existing ones, the hard-coded credentials, I introduced 2 new problems. We can literally drill down on these problems. And yes, I have the cross-site scripting in there, and I have the SQL injection in there. And as a code reviewer now, what I would see is literally, yes, the pull request is there. The check did not work out. Okay, I can drill down on the check. I can drill down on the details that they are. I can have the same experience that the developer had. If I can find the way to click here, I can have the same experience, moving through the code, seeing all the things, jumping in between files if needed, and stuff like this, So all is there, and it helps me in this regard to kind of, do the code review, react on the code review. And this is the first, so to say, position in time where a developer that is not using the tool would actually have a hard landing, because the tool now comes up with the same results. One thing that is quite interesting to say is this is the same rule set that we are using all the time. So there is no surprise. I cannot come up as a developer and literally say, oh, I didn't see this in my IDE because it wasn't there. No, it's the same rule set. We are using the same big rule set, the same containing everything rule set throughout the whole SDLC, throughout the whole CI/CD pipeline. Okay, one more thing that I would like to show you is this. So I have a little Jenkins server here. So as you can see, this is a Docker. It runs a Jenkins server, and this is it, my Jenkins server. So my Jenkins server has a project that I set up that is called car sharing telemetry. And to configure that project, I had to do 2 lines. So the one line was the repository. So where do you find the code? Okay. The other line is this, Snyk code test, your current directory. With this, I have the the static code analysis implemented into my CI/CD pipeline. This is all that you need. We have a better way of doing this. There is a plugin for Jenkins, and the plugin takes care of updating the Snyk CLI, and a lot of these things are also happening behind the scenes. So please don't do it like this. Use the plugin. You know, the plugin is better. But what I wanted to show you was how easy it is. You know, how easy it is literally to use that. Now we can press build now. So we are setting up a new build run. And we can have a look at the console output, and you see, you know, there are some branches in here. I should delete some of them, I think. And then the code test is running, and there it is. It's done, you know, which again shows how fast we are. Nothing has to wait for the static code analysis to finish. And you see, it's a failure. Yeah, because we found some high issues in here. This is the last point where the CLI would kind of within the CI/CD pipeline would so to say stop the propagation of that code. Okay, so back to this one. What I wanted to show you and what I showed you was I used the red circled elements here. So I used WebStorm, I used the GitHub integration, I used the Jira integration, PR scanning, the CLI. I did it in JavaScript, and I used Node. But as you can see, there's much more. And we are moving very, very fast. As of now, we're literally adding a new supported language every month. So we are looking down. PHP now is one of our most used languages. Amazing to see how the usage of PHP. Ruby is coming up currently. We are working on Golang, Kotlin, you know, so a lot of these languages are in the queue. And the way we're doing it is we are setting them as betas. So whenever they reach a certain kind of threshold where we say from now on it's valuable, we are not done with the language, but it's valuable to use already what we have in here. We are publishing it as a public beta. You don't have to do anything. It's just continue to scan your code, but these languages will also be recognized and will also be used in that perspective. Libraries, same thing. You know, we are learning automatically these libraries, so we are adding libraries on the go as we learn these languages. Okay, summary. I think it is time to rethink SAST. So if you think about SAST as something, let's schedule a scan and let's wait for maybe a night or even weeks until the scan comes back. And then you have lots of false positives and you need to wait through them and it's hard to understand what you're doing there and it's not really actionable. Think again. What I just showed you was, I forgot to count, but I did a lot of scans and all of them were real time online. Okay, so it's like the real thing. So scan times are now down to minutes, maybe even seconds. And with this, you can literally use tool within your workflow as a developer. You're reaching a certain kind of maturity in your code. Yeah, you scan it. You're working on the results then, and you scan it again. And you scan until you find that you reached where you want to be. And then you do the pull request. And then it's scanned again. And the scan in this is then within the pull request. As a code reviewer, you can work again on this. And if you put it in the CI/CD pipeline, we scan it again. And you will see what is kind of going through the CI/CD pipeline in this regard. So this means all of a sudden, SAST doesn't need to be this kind of a humongous thing that is running in the background anymore. It's a kind of a natural thing that you are using all of the time. And you are rescanning whenever you feel like. Yeah, so this is what disrupts, in a way, this whole SAST idea. What also disrupts the idea is that we are now able to learn from the code that is out there. So we are learning from the knowledge of the developer community globally to kind of increase the knowledge and the findings and the accuracy of the engine. And this is done more or less automatically. So we are exponentially growing our result set. Nobody has to literally sit down and codify everything. No, we are learning things. So we are growing exponentially in this regard. Okay, so the idea then is, and this is like the summary of the summary, SAST can be an active part in improving your organization security. It no longer needs to be this reactive thing where you scan and you have the reports and nothing happened, but it can be an active part in it. So scan results immediately lead to fixes. And these fixes are done before the code even goes down in the source code management or in the CI/CD pipeline. Okay, there's a question. What about PowerShell? In a way, so the CLI that I showed you is an NPN project. So it's a Node.js project. It is massively, how should I say, configurable by using kind of parameters and stuff like this. What would be an interesting thing now that you mention it is to take it apart and literally take the Node.js sources and open them up in a way that PowerShell does it, by piping things into it, by, so to say, use it as a .NET component in this regard. That's actually an interesting idea. In a way, it's a Node.js application, and you are welcome to kind of have a look at it and take it apart if you want to. That said, one word of warning, we are regularly updating this. So be careful, not to fork it and then, so to say, be frozen in time with one version that you have, but to keep it in a way that you can follow the updates that we have there. Okay, do you have more? Yeah. You're welcome. Okay, thank you. Do we have more questions, more comments, more things you would have liked to see? Yeah, so I have this nice slide showing you, throw questions now. Make them soft as possible. Okay, we had the PowerShell question. A typical question that comes up is about the secrets that we find, and I showed you in the examples that we find these hard-coded secrets. And in a way, it was just yesterday that I had somebody that actually ran into this problem like head on. So it is common. It's all over the place. The way we are doing this, and maybe I go back here and literally have a look at it. So let's go to the project. Let's go to the index. No, we need to go to this one. There we have it. The way we are doing this is, so you saw this one was so to say flagged, and it showed two were flagged actually, and it showed yes you're using this. The thing I saw how this type of scan is implemented in a lot of static code analysis tools, some very famous open source ones, for example, is that they are literally having a regular expression. They're saying, hey, I search for something that has password in the variable name or something like that. We are actually not doing this. We are also not looking out for what is called the Shannon entropy. So some applications are literally scanning your code. They treat the code as text, and they're looking for text that is so random within the source code that it must be a kind of a key. Yeah. And when this happens, they flag it and say, hey, there you have a key. Because it's so random, it cannot be any kind of sensible code. We're not doing this either. So the way we are doing it is we know that there is something that is called MySQL within Node.js. You can have this as a requirement. You can bind this in. And then we know that this variable, MySQL, this object, is actually of the type that comes with this. So we know that. Now we follow MySQL through the code. I mean, here it's quite easy to follow. We would follow it further if needed. So we know this MySQL is actually this MySQL. And we know that within this one, we have a function that is called create connection. And create connection is a sink. And this sync function should not be fed on two parameters, this one and this one, with static content. So we know these variables now are static, and we know that this is a typical sync function that should not be fed with static content. And by this, we know this is a problem here. We have a hard-coded credential. We found it. And this is done by a data flow analysis. It's not done by Shannon entropy. It's not done by a regular expression searching for password. It's done in a way that is the data flow analysis. So even if you would define password somewhere else as a static, and you would then integrate it here, it would still flag it because we know, how the data is flowing within the application. Okay, good. Any more questions from your side? I think we have like 5 minutes left. Otherwise, the thing that is left to me is invite you. Okay, simply go to snyk.io, set up an account there. If you don't have one, set up an account there. You need to have GitHub credentials or Google credentials or something like this. You need to have some of these credentials. You can set up an account there. As I said, no credit card needed, no nothing. And then you can already start scanning applications and see the results. And one thing that I want to show you here, so you will see like this dashboard. When you log in to Snyk, you will see the dashboard. And you see I have like 1,000,005 different projects here. What you can do is you can simply add project, and you can monitor a public project. So by going to GitHub, using a public repository that you find there, you can then, so using actually this here, you can then add this as a monitored project, and you can see what is coming out of it. You can see, so for example, I added the OWASP benchmark here. This is a massive one, because it has like thousands, like whatever, 2,500 issues that are coming up here. Obviously, it's made for this. But as you can tell from this book, it's a public repo. I did not upload myself the code. It's a public code that I can see here. And I think this is the easiest way of testing it out. Okay, so simply take an account that you have there, private, or if not, if your company doesn't allow it, use one that you simply make up, and you just can scan open source repositories, and you see results, and you can drill down, you can work with it and see how it makes sense and stuff like this. That's the easiest way of doing it. Okay, good. Well, that was me. I think well, I came through with my demo. That is good. So you saw all of the steps there. I hope you also had the opportunity to see the idea that is behind open source, and that leads us in building open source in this regard. Also, the idea of what we are supporting, what we are about to support, and how fast we are moving, and the idea why this can happen. What is the secret sauce behind the whole thing to make us move so fast. Okay, if you don't have any questions anymore, I would say it's like 2.5 minutes before time, but it's a good ending that we have here. I hope you enjoyed it. I hope you learned something. I hope you try it and you give us feedback if you see something valuable, if you miss something, give us feedback about it. We're constantly developing on it, we're constantly trying to improve it. That said, I wish you a very, very nice day. At least here where I sit, just the sun came up, and you see the overexposure that I have, so the sun is now shining, so this is good. Yes, I wish you a good day. And yeah, if you have more questions, just stay here, put the questions in, or yeah, reach out to us in any of the known channels. Thank you very much. Thank you.